Good morning. We have a number of our government customers who are using the mission engineering process, and most people use SysML to model the aspects of the mission architecture and the mission engineering threads. And so they came to us and asked, well, we think we might find UAF useful. Can you help us understand how UAF can be used to support mission engineering? So most often when you're doing capability portfolio analysis, you're mostly focused on cost, schedule, and performance. But even if your cost is affordable and you're meeting the performance specs and you can meet the schedule, there's still the question of, okay, we spend all this money, are we spending the money well to deliver effective missions? You know, in other words, bang for a buck. That's basically what we're trying to look for. So you need some way to measure mission effectiveness beyond just the cost, schedule, and performance. And that's where the mission engineering process comes into play. So the key part of the mission engineering process is define the mission threads. Think of that as in the operational domain. And define the mission engineering thread, the resources that contribute to performing the mission tasks. And when you combine mission effectiveness with cost, schedule, and performance, you get a much better picture of what are you getting for changing my portfolio. So the mission engineering guide has been around since 2020. They're soon to be issuing version 2. And so you can easily define, just Google mission engineering guide, it's the first thing in the list. And it's relatively short and compact, only 50 pages, but it's really packed with a lot of good information. I highly recommend, if you've never seen this, I think even though it comes out of Department of Defense, I think it's very applicable to any kind of business or any kind of mission. It doesn't have to be a defense, because it's just basic. It's in a way, it's like system engineering at the mission level. So in the guide, they provide a 6-step process. So the first 3 steps is defining the operational context. And the first step, of course, is defining the problem. It's amazing how often people do this and they don't spend much time defining the problem. They just go immediately into the solution. You know, we engineers, we already know what the answer is. You know, we don't need to tell what the problem is. So it's all about figuring out what you suspect the capability gaps are. And as you go through this process, you often find out what you think the gaps aren't the real gaps. And that's one thing you want to keep your mind open. Don't just assume that these are the requirements and all we have to do is, meet all the requirements. Well, your requirements might be wrong. Okay, a lot of the requirements are just copied over from the previous system or the previous mission. So a key part of architecting is assuming all requirements are wrong and do architecture modeling and assessment to try to figure out which requirements are even worth carrying forward. Maybe you can get rid of all the requirements. So mission engineering can really help that, as long as you're open minded that not all requirements are equal and not all requirements are still requirements. So the big part of the process is step 4, where you're designing the analysis that you're going to do. And that's not a trivial step. You have to design the analysis well. And of course, step 5 is turning the crank on your analysis. I mean, it's often simulations, but it doesn't have to be simulations. It could be other kinds of analytical tools, whatever it is. But step 4 is where you design what tools and methods and techniques you're going to use for doing the analysis. And of course, the last step is just document the results. So a little bit more on the step 4, design the analysis. That's really where you're defining the core thing you're evaluating. It's the mission threads, because it's mission threads that deliver mission effectiveness. Okay, but missions don't run without resources. It's no good just to have a logical mission thread and say, okay, that's great, just turn the crank. Well, you have to turn the crank on real world things, and that's what the engineering does, is apply real world things like systems, software, services, technologies, even natural resources, all the kinds of resources, and all those things are defined in the resource domain of UAF. So that's where the mission engineering threads is applying the resources to the mission task, but also look at alternative mappings of resources to these mission engineering threads. And even more, have alternative mission threads. Okay, so it's really analysis. It's alternatives in 2 dimensions. At the operational level, alternative ways of getting the job done. And then at the resource level, alternative mappings of things in the real world that can help you get the job done. So the mission thread, somebody asked earlier about vignettes. So there's no element in UAF yet called vignette. So we are working on, as Aurelius mentioned, we're working on enhancing the ontology of UAF so we can incorporate all the ontological concepts in the mission engineering guide. Of course, it's not the only way to do mission engineering, but at least it's well documented. And as we flesh this out, we want to make sure at least everything you see in the mission engineering guide, you can find somewhere in your UAF model. It may not be exactly called a vignette, but at least we can tell you a vignette, you model it as this thing in the UAF. Same with scenarios. Scenario is basically a combination of various vignettes. And there could be multiple mission threads, which is just some sort of ordering or sequencing of tasks to support that vignette. Whereas the mission engineering thread is where you apply, this just shows systems, but we all know the total solution is not always just systems. You know, you have non-system solutions such as processes, policies, education, training, facilities, and so on. So of course, being good modelers or good architects, we need to go model the mission thread. And this is a typical kill chain, find, fix, track, target, engage, assess. And that's all in the operational domain. But then you go down the resource domain and you apply resources to support those tasks. So the mission architecture is first, what does the mission environment look like? Who are the players? Who are the actors, if you want? Or what are the operational nodes? What are the platforms involved in conducting the mission? But then you go into model space and start modeling all the mission activities and some sort of behavioral sense of how will the mission thread be conducted. And then you go down to the physical domain and say, what are the physical things that are helping the people doing the operations to be able to conduct the mission and meet mission objectives. So of course, when you do all this, you get a bunch of models of the mission thread, mission engineering threads, and a bunch of other things. So the question is, how does UAF help? Well, let's go take the mission engineering ideas and map them to this and see what it looks like. The capabilities and threats, that's well documented in the strategic domain, capability taxonomy, capability connectivity, capability dependencies views. The mission thread is in the operational domain, and the mission engineering thread is picking up, mapping the resources from the resource domain back up into the mission threads. But notice all the parts of UAF they're not using. So UAF has a lot to offer beyond just focusing on just getting the mission done, because there's more to mission success than just successfully executing the mission threads. Okay, and you have to understand that when you're doing your mission architecture trade-offs. So there could be services. What about the idea of using GovCloud as a computing infrastructure service, a common service across the government? Or what if it's using commercial telecommunication services? Instead of building our own, why don't we just treat things as services? So the service layer allows you to look at things from a service layer. So you might even think of mission engineering threads that are composed of services and not systems. Okay, I don't see too many people in mission engineering taking that approach. I mean, SOA was big 20 years ago, but they kind of stumbled and now they've forgotten, but a lot of good service-oriented architecture. And one thing we've done with the services is as we evolved UPDM to UAF, we put in some of the service-oriented architecture concepts. And as Aurelius mentioned, we're not quite there yet. We had several-hour discussion earlier this week about what are some things that are missing to help us better define the service architecture. The personnel, people are important. Not everything in your mission task is automated with hardware and software. So then there's a trade-off between how much of the task is be done by the people versus how much is going to be done by the machines. So there's that human-machine trade-off you have to make. And it's not necessarily true that automation is necessarily good. sometimes you want to take things that are automated and maybe use the people in a different way. And that's what the personnel domain can help you do. Security, that's very important. Sometimes it looks like the mission's going to succeed, but we didn't account for security threats. So you may think you're going to have a successful mission, except the bad guys have different thoughts on that, and they know how to get into your network and mess you up. So you might want to model some of the security and say, are we going to be resilient? Do we have the right protective measure? Do we have the right security controls in there? Projects. Okay, you can have all the resources laid out in a very nice way and showing how you get this great mission performance impact by doing this stuff. But if the projects don't line up, so at some point you have to decide what projects to kill, what projects are new, what projects to modify. And it's not just system development projects. You may need a project to redefine the policy, or a project to go train people in new ways of doing things. So these other layers can really enhance the mission engineering. The mission engineering guide doesn't mention those, but there's no reason why it can't be enhanced to take advantage of more of what UAF does. Then there's the idea of roadmaps. Just because you've decided what all the systems are to conduct your mission threads in a more effective manner doesn't mean you can ever get there. You define the end state, but you have to define the intermediate steps to get there in the roadmaps, capability roadmaps, system roadmaps, and project roadmaps. Sometimes you have a great plan, but it's not implementable from a programmatic constraint perspective, or maybe a funding constraint, or maybe it's you don't have enough of the proper skill sets in your projects to actually deliver the systems that you're imagining. So one thing UAF provides is an enterprise ontology, and this wasn't just made up a few years ago. This is built upon 30 years of continuous development, going way back to the C4SI architecture framework, and then DODAF, now UAF, and it's continuing to evolve as we flush things out, like the service domain. We know, and mission is not represented here much, but we're trying to fill in the ontology with other things. So the UAF specification has 3 main components, which Aurelius already covered. But the new component came out last year, the Enterprise Architecture Guide for UAF. So our plan is, in fact, we're already starting to develop a mission engineering guide for UAF. Okay, so if you want to help us, give me your card. You can always use help. But the mission engineering guide doesn't need to be as big as the EA guide, which is 140 pages, because we already got the mission engineering guide. All we need to do is show how you apply the enterprise architecture guide to the mission engineering process, which is already well defined. So we're also going to develop a mission engineering reference model. So you have a reference model as a starting point. So if you don't already have a model of your mission or a model of your mission engineering thread, here's a starting point, and it's just kind of like a template. So that's going to go with the mission engineering guide. So the real advantage of the grid is it helps you separate concerns between these different stakeholder viewpoints. So at the top, strategically, what's important? And then operationally, how are we going to achieve those strategic objectives? And then everything in the middle is like all the kind of resources like services, standards, personnel security, all those things you do in engineering space. But at the architecture level, you need to be aware of what you can do engineering-wise and technology-wise and so on. So the yellow box in the middle is where you do analysis of alternatives. So we use the layers of abstraction in the grid to lay out a reasonable workflow. Now, this is not a process diagram. This is really more like an information dependency diagram. Or if you're familiar with decision analysis, you can call it an influence diagram. So it shows the connectivity between the views is how this view can influence that other view. So these are not flow lines, they're dependency lines in a way. So the question is, you got the 6 steps you're doing, what's the best way to use UAF to help define the mission architecture? So that's the first step, is we've defined a complete mapping between all 240 steps in the UAF workflow and these 6 steps of the mission engineering guide, but it didn't do us any good to map at this level. So what we had to do is we had to go take the mission engineering guide, the 50 pages, and we had to go read the paragraphs and basically parse it out in terms of more granularity, because we need to map down to a level that makes sense. Like, for example, 225, define the red and blue forces. Okay, so there may be specific views where you can actually see what the red and blue forces are and how they're defined. So we actually modeled this process. This process is not in the guide, but we're putting it in our reference model. So we have a model, and it's a 3-level composition. And the UAF workflow is already modeled. We model that in Cameo, and some of the other tool vendors are also modeling it because it's basically just the workflow. And these, as I said, this is not a process diagram, although it looks like a process diagram. These are dependencies between these views. So then we took the UAF workflow model and the new mission engineering workflow model, and then we started mapping. So this is just a simple mapping of 1 step in mission engineering, step 4, design of analysis, and step 3 of UAF workflow, which is your operation architecture. And you can start to see how the mission engineering takes advantage of the views and the UAF workflow. So this is the model version of it. This is again just a portion, step 4. But here you're mapping to not the steps of the workflow, but to the actual individual UAF views over there. Notice there's 2 kinds of relationships, because the mission engineering step can create a UAF view, or it can use the view. So subsequent later steps in mission engineering can use the views that are created in earlier steps. Now, of course, after you've done this a while, you've got a library full of all these views that are probably 80, 90% what you do. So one advantage of using a standard is that you start building up a repository over time, and then you can just go in the repository and find what you need, and you're not starting from scratch anymore. A lot of people do SysML, and they have their libraries, but there's not consistency because everybody's extended it in a different way. UAF already has done the extensions. We have 240 stereotypes, standardized stereotypes in the or in the view specifications. So this shows the mission engineering steps to the views and back to the workflow steps. Okay, because it's really a 2-hop process. So all this is modeled, and we're currently writing a 50-page. Our white paper for our customer is currently 50 pages, and we have the complete mapping of all the UAF workflow and all the mission engineering steps we defined. So to conclude, what did we learn? Well, we already knew that UAF is designed for enterprise, but was it designed for missions? Well, we found some shortfalls, and the UAF working group is having meetings to discuss, what can we do to enhance UAF from a view perspective, from a model element perspective, from a connectivity between the model elements perspective, the names of things, like what is a vignette in UAF? Do we need an element called vignette? Or do we just declare that's an alias for this other thing? So we just have to figure that out. But we did discover there are some missing entities and relationships in the meta model and some properties. So we're working to put that in there. So it's pretty good at enterprise. I wouldn't say entirely good at all aspects of enterprise, and it's pretty good at mission. But we discovered some really good enhancement that we need to make. And we're starting to build in fact, Matthew built a mission architecture model that he showed us this week to see if these mission engineering concepts actually work in the real model. And by modeling it, he actually discovered, oh, this doesn't quite work like we thought it was. So we're using the prototyping of a model of our new schema to see if it's actually going to help us do many. Now we need to work with people who are doing real mission engineering for real. He just did it for a Star Wars Battle of Hoth sort of operational architecture, which is kind of a toy problem, but it's still, he learned a lot, and we learned a lot. So the mission architectures and mission threads, those are key to driving, modeling, and simulation. Okay, but the modeling simulation, the simulation results need to be tied back to the measures of success that you defined in step 1 and 2 of the ME process. So we can currently use UAF out of the box right now with mission engineering, and you might need to do some localized extensions, but eventually we'll have those extensions in the standard. So I think one key thing about UAF is it goes beyond just the mission, because mission success is more than just getting the mission task done. There may be some policy issues, there may be some organizational issues, there may be facilities issues, there may be issues with the so-called shared services and so on. But if you haven't modeled services, how would you ever know that? If you haven't modeled the programmatics of your project timelines and how that maps into system roadmaps and how that maps into capability, how do you know if you can ever actually get to this perfect end state that mission engineering has figured out? So that we think UAF can really help you answer all those other questions that are important beyond just, how do we map these new systems we want to buy to the mission tasks and figure out how we can improve performance. It's not quite that simple. So stop here and see if there's any questions.
Yeah, we have time for some questions. Yeah.
I have a question.
Hold on a second. Go ahead.
Okay. So this is Peter Adejokum from Lockheed Martins.
Hold on one second, Peter. Hold off on your question.
Okay.
So I know a lot of us have DoD clients, and with the missionary engineering guide being DoD centric, have we started to look at and map the mission engineering guide and these UAF processes back into the JSIDS process? Because like it or not, a lot of our clients are going to be like, hey, I need a CBA, I need a CDD, I need an ICD, I need a document in order for me to get this piece of equipment through because Congress says I do.
Before you have the ICD. So that's the initial capability document. So if you have an ICD, we can go model that. But what the next question was, can we do a model and then generate the ICD from that? So then we have a complete coherent architecture model that answers all the questions. Then just push a button, boop, there's your ICD. Same with the CDDs. We actually modeled an ICD and a CDD for a couple of our customers, and we created a template. And we also discovered some of the things that are in the CDDs aren't in the meta model, and we want to enhance things there too. So that was a different customer, but so one of my internal research projects is to take what we did for that customer on the JSID space and this on the mission engineering space and merge those together. So yeah, that's where we want to take it. Yeah, somebody online had a question. You still there? Anybody else in the room?
Any questions? Any other
Yeah, I'm here. Aurelio, can I just go ahead with my question?
Yeah, go ahead.
All right. A very good presentation. We have similar things related to mission engineering that we're looking at, but the artifacts that were provided in terms of, to start with, use cases, the vignettes that you talk about, and then the thinking was to do a BPMN
Right.
to capture the flow. Does that have is that part of the thinking for this? Because
Yeah. Well, I have a third customer that we're actually modeling their business practices using BPMN, because once you do that, then you could use automated workflow tools, and BPMN is well designed to work with those automation tools. So systematic activity diagram, I guess you can automate that workflow. I'm not too familiar with that, but BPMN is kind of designed for that. So what you need to do is figure out where BPMN, business process model and notation, is a better techniques for modeling a process versus using system activity diagrams, which is the basis for most people who use UAF. Although the Cameo tool allows you to pick. You can just plug in the BPMN model and do your process UAF models in that. So yes, that's where our thinking is to not necessarily be even limited to SysML. Like SysML doesn't have the notion of timing, so our UAF roadmaps aren't based upon UL. I mean, some things were extended, but there's no notion of a timeline. So yes, we need to expand UAF to cover these other areas, but we also recognize that UAF is not the only framework that covers everything else. We have a customized tool called Portfolio Decision Support Tool that we've had for 20 years. And that does a lot of good things. It speaks the language of decision makers. So we're trying to connect our PDST tool to our architecture tools and the project management tools, the cost tools. So we need to hook the MBSE tools, the analytic tools. So there's a whole ecosystem, you might think. Another question?
One more question here.
Okay, we got one more question in the room.
The last one. Yeah, the last question.
Where was it?
So Dr. Martin, can you talk to that feedback and from a UAF perspective, I guess it's on slide 21, back to challenging, do I have the right problem? And additionally, if I don't have the right problem, if I need to change the problem or change some assumptions in the problem, because in analysis, I found out that I'm thinking about it differently. So as I feed that back, does UAF, what considerations do I need to rationalize that? What view, fit for purpose view, with all that information abstracted to a higher level? Because sometimes when you find a change in the problems, that goes to a higher level decision maker. So now but they're not modelers. So what UAF considerations in creating a fit for purpose view that has many elements on it, abstracted to a higher level? What considerations do we have to think about, or is that something that UAF doesn't support? Is that another tool?
I think what you're pointing out is what I tell people is architecture modeling is not architecting. And you're saying, well, can the architecture modeling help me do the better architecting to maybe realize maybe we defined the problem wrong? And they do have a feedback step from step 5 to step 4, but why don't they go all the way back to step 1? Because sometimes you need to go back to step 1 and redefine the problem because you've learned, oh, that's not really the problem. Yeah, so the mission engineering guide doesn't really address that, but architecting, this is mission engineering, it's not architecting. So architecting is an overarching because mission is not the only part of the architecture that's important. There's programmatics. There's a social issue, there's legal issues, whatever. So architecting has to be an overlay. As someone mentioned earlier, on top of this, in fact, the Airbus, on top of all this needs to be the method, which is tool agnostic, framework agnostic. You need the proper method, and architecting provides a good method, so to speak. Okay, thanks.